Every trend-following system faces the same problem. Fixed percentage stops don't adapt when volatility itself is changing. The NRTR adaptive trailing reverse indicator addresses this directly by rebuilding the classic Rypock trailing reversal method with a volatility-aware core and 8 selectable smoothing engines. At the heart of this tool is a dual-mode trailing calculation. Traders can choose between a fixed percentage offset or a dynamic ATR-based offset, where the trail distance expands and contracts with recent volatility rather than staying static. This ATR multiplier approach means the trailing level breathes with the market instead of ignoring regime shifts. Before the trailing calculation even runs, price is optionally passed through an adaptive source filter. Users can select from SMA, EMA, RMA, WWMA, triple VWMA, HMA, a custom Llama slope projection filter, or a Kalman filter. The Kalman implementation uses a simplified recursive gain formula, updating its estimate and error term bar by bar to smooth noise while tracking directional shifts with reduced lag. The Llama filter blends a moving average baseline with a linear slope projection, offering a different smoothing character than traditional moving averages. The core trend state machine tracks a running extreme price and recalculates the trailing stop level relative to that extreme. A trend reversal is only registered when price closes beyond the current trailing level, at which point the extreme resets and the trail flips direction. This is the mechanical definition of state change in this system, not a predictive signal. Layered on top is an optional ADX/DMI confluence filter, requiring directional movement strength to clear a user-defined threshold before a state change is treated as valid. A cooldown guard can also be enabled, which suppresses new state changes for a set number of bars following a stop-level breach. This is a mechanical rate limiter, not a performance claim. For structural mapping, the script calculates ATR-derived risk zones, an entry reference, a stop-loss level drawn from the trailing calculation itself, and 3-tiered R-multiple extension levels, 1R, 2R, and 3R equivalents, plotted as visual reference lines with line fill zones between them. A position sizing calculator, risk percent or fixed dollar mode, demonstrates how theoretical size might be derived from a stop distance, purely as a math demonstration of risk-based position sizing formulas. Everything is summarized in a real-time on-chart dashboard showing trend state, trailing level, ADX reading, active filter type, cooldown status, and a visual proximity bar showing how close price sits to the current trailing level. The script also generates structured JSON payloads for each state change and level touch, formatted for webhook-based automation pipelines. What you'll learn from this breakdown: how NRTR, Rypock Trailing Reversal, logic constructs a stateful trailing level using an extreme tracking variable. The mechanical difference between percentage-based and ATR-based volatility offsets. How a simplified Kalman filter recursion, gain, error, estimate, can be applied to price smoothing. How ADX/DMI confluence can be used as a structural filter for state change validity. The mathematics behind R-multiple risk mapping and risk percent-based position size formulas. How to structure webhook JSON payloads for automation pipeline integration. Warning: educational software for analytical purposes only. Trading involves significant risk.